Good afternoon, everyone. So, today we are in the eighth session of the problem solving classes. So, my name is Praveen Maiti. I am TA of this course, and the course name was Symmetry, Stereochemistry, and Application. And course instructor was Professor Usman Raju. So, earlier classes we have talking about that some substitution reaction and elimination reaction. And before earlier, we are talking about that symmetry of a element and stereochemistry, all of this, and name of you can name of compound. So today's classes we are mainly focusing about that some addition reaction. So today's problem will be on some addition reaction problem. So addition reaction mainly there will be main type of addition is Markovniuk of addition. So like this, and question was the predict the following products. So we have to find out the what are the products of the following reaction. So in this reaction, these are the Markovniuk addition. So Markovniuk addition. So our product will be more stable carbocation. So first what will happen? So this is our solvent Ta THF tetrahydrofuran, and this HBr is addition into this double bond. So the addition reaction are mainly favorable because the addition happen in the pi bond, and if you compare that um, the overall energy, so addition reaction why favorable. So if we compare the overall energy as compared to sigma bond, so after this pi bond break, there will be given the sigma bond. So here mainly from pi bond to we are going to that sigma bond. So, and that total energy of that sigma bond. So, total energy of two sigma bond, there will be total two sigma bond are produced. So, total energy of this two sigma bond is greater than the sigma plus pi bond. So, the energetically, this the reaction is favorable, and this the energetically favorable reaction, and these are also the exothermic reaction. So someone asks about the why that in a double bond or in a pi bond there will be addition reaction happen, because this are after addition, so there will be some formation of sigma bond, that is two sigma bond are produced instead of one sigma and one pi, and these are energetically favorable process. These are exothermic one. So any reaction happened when the product will be mass stable. So then this reaction will be happen there. So if you consider the energy diagram, so our reactant will be here and our product will be slightly energetically favorable. So if we're drawing the energy diagram, so our from the reactant our product will be stable. So this for the reactant coordinate and this for the product. So this is the energetically driven process. So we get the product. Now we have to know that for that Markovniuk addition, so what will happen? Our that Br will be added at the position where the substitution is less. So if you found that product, so the reaction will be going on like this. So this the reactant. So first this HBr. So HBr, so slightly del positive here. And this is the pi electron cloud. So pi electron cloud have some del negative, so it will attack this. So hydrogen abstraction happened first. So if the hydrogen abstraction happen, then the reaction will be like this. So there will be one methyl above the plane, and so hydrogen abstraction will be here, and here the positive charge will come. So now what happened? Now we have in that reaction medium we have Br minus. So now Br minus can attack from this face or this below the face. So like an SN1 reaction, so there will be two probability of Br minus. So it will be attacked from upper or down. So then our product will be like this. So the methyl is above. So here one thing we have to remind that any addition reaction, Markovnikov addition reaction. So first the stable carbocation produced, and where the stability of carbocation is higher, so that side will be major product. So here the two possibilities. So each can attack here, each can abstract here or here. So there will be two probability because this methyl is far from this region. So there will be two product can possible, and for every product there will be two chance of Br minus can attack. So total four product will be from. So what are that product? So Br so one is above the plane, and next will be Br will be below. Similar thing when hydrogen abstraction is happened here, so carbocation is generated here. So there will be another product will be like this. So when Br will be at first, second position as compared to that methyl. So first one the Br is the second position and last one will be Br will be in that position. One will be the above the plane, and one will be below that. So these are the Markovnikov addition. So Markovnikov addition, what we have to remember. So first you have to remember this process at the exothermically energy driven process, because from sigma pi bond 2 we get that two sigma bonds which are energetically more higher energy. So product will be much more stable than our reactant. So it will be forward reaction are taking place. Next, we have to find out that where the more stable carbocation are produced. Like here, the two possibility of carbocation produced here and here. So here will be two chance of product of two. Two product can be possible. maybe two product can 50-50 can possibility, and also BR minus can attack from above the plane or below the plane. So this will be our product. So total four product will be possible here. So now the next example one. So next example was the similar, but the where the methyl is added in the double bond. So here our product, what will be our product? So first this HBr. So if the HBr will be attacked here, so there will be two possibility. Then hydrogen can addition here. One is it can add it at the methyl position and it can add it at that this position. But the most stable carbocation will be produced when hydrogen will be in that position. So why? So this will be like that. If that hydrogen will be attack here, so what will happen? So there will be two possibility hydrogen can attack. But the most major product will be where the stable carbocation is formed. So one possibility is like this, where the carbocation is generated here and hydrogen is here. This will be one possibility. And next possibility was, so this one is methyl and carbocation generate here. So these two possibility happen. But if we show the stability of carbocation, so this will be like a 2-degree carbocation. So stability of carbocation is higher. So here the product will be, so this product will be major product. So what are the product? So now the Br minus attack here. Br minus also attack from two phases, from upper phase and lower phase. So this will be the above one is the major product. So because of the stability of carbocation. So what do we have to remember? Stability of carbocation. So which have the higher stability of carbocation? So that will be give your major product. And which are the less stable one? So that one will be given your least product. So this will be like that. So now here the two product can be possible where the Br minus is above and down the plane. So one case is like this. Then is above and here is below. And the Br is above. And there is below. So this will be our major product. here the 2-degree carbocation are produced. So these two are will be major product, and least major product will be at the Br will be attack at second position as compared to the methyl. So here are also probability of two product. One cases the Br is above. Another case when the Br is below the side. So for Markovitch addition, what we have to remember? So we have to remember that where the more stable carbocation are formed. If the more stable carbocation are formed on this side, so these are giving the major product, and generally the substitution happen. The larger group substitution happen, and for the Markovitch addition, the Br will be attacked at the position where the substitution of the uh, molecule is higher. So the had the methyl has the more substituted position. So here the Br will be attacked. But if we are go the anti-Markovitch, so next we have seen the anti-Markovitch addition. So where that Br will be attacked here, where the least position are substituted. So now the next example one. So now the next example a example of that sodium borohydrate and lithium aluminum hydrate are generally the hydrate store right source of any product. So generally the lithium aluminum hydrate can reduce anything, but sodium borohydrate only reduced that ketone and aldehyde, but not reduced carboxylic acid and esters. That we have to remember. So if you want to remember that, also in your class you saw that sodium borohydrate can only reduce carbonyl and aldehyde. So from carbonyl we are getting 1-degree alcohol. So what do we have to remember? So for carboxylic acid like COOH and COET, this one is our ester, and if there will be ketone group, and if there will be some aldehyde. So and if your reagent will be like that LiAlH4, and another reducing agent like this example NaBH4. Li LH4 are more reduced any carbonyl center or any center, but NaBH4 only reduced this 1-degree carbonyl and aldehyde. So from carbonyl it we got that 2-degree alcohol, and for aldehyde we got 1-degree alcohol, and there will be no reaction for acid. So acid and ester not reduced by NaBH4, but LiAlH4 reduced all acid, ester and all things. Again reduced and produced alcohol. So it produced 2-degree alcohol. So in this reaction, so what will be, one is carbonyl is present and another is ester group are present. So ester are not reduced by NaBH4. So when we are uh, sequential reduced only one carbonyl center but not reduced the another carbonyl center, so then NaBH4 are good reagent for this. So how the reaction is going place? So in a carbonyl center like this, methyl. Like this ethyl group are present. So only NaBH4 reduced this carbonyl center only, but not reduced. Oh, there will be double O it. But not reduced this center. So only reaction will be happen. So this reaction will not happen. Only this side reaction. So what will be our product? So our product will be like this. So carbonyl 2 we get 1 degree alcohol. So this will be our OH. 2 degree alcohol. So our COOAT as it is, it will be present. But if you go LiLH4 in this reaction, so then what will happen? And these two are all are reduced. Center and this center all are reduced. So how the reaction is taking place? So in a carbonyl center, what will happen? So as general example I have given in a carbonyl center, if we given NaBH4, so generally NaBH4 like this, Na plus and BOH4 minus. Is 3 and there will be one hydrogen. And here the boron have the 3 position, but there will be 4 hydrogen, so this will be minus. So what will happen? This hydrogen will be attack here, and this will be become O minus. So our carbonyl center will be like this: O minus plus. Reaction medium there will be water. So water also that source of hydrogen. This O minus attack one hydrogen here, abstract one hydrogen. So our product will be like this. So what do we have to remember here? So we have to only remember that LiAlH for lithium aluminum hydride can reduce any center, any carbonyl carboxylate and aldehyde ketone center, but when there will be both carbonyl center and ester center are present and we are given NaBH4, so NaBH4 only reduced that carbonyl center but not reduced any carboxylic acid center or ester center. So next example one. So next example here we are given LiAl. So this one is similar like LiAlH4, but that the hydrogens that the strength of reduced the reactant for LiLH4 is much higher as compared to this. So this only reduced our ketone to aldehyde, but not ketone to fully in alcohol. So what will happen? So only our ketone will be reduced to aldehyde one, not in alcohol. So what will be our product? So this double bond also not reduced because their hydride source, the lithium aluminum hydride, is not. So this will be convert into ketone to aldehyde. So I am drawing here is the 1, 2, 3, 4, 5 carbon is present. So carbon will be 5. Double bond is here. 3, 1, 2, 3. So this become aldehyde. If given here the LiL is 4, so if the source of the reducing agent is LiL is 4, then the product will be, so all center are reduced. So then the product will be this. It will be OH. Like this. So this center and this center, both center are reduced here. But when we are given that LiO beauty, some substituted one, so then that strength of this hydride source are not enough to reduce all the center, and so only that reduced aldehyde to carbonyl, carbonyl to aldehyde only. So now the next example one. So here is the lithium aluminum hydride source. So what I tell, the lithium aluminum hydride can reduce all that thing. So what will be our product? So for the reaction, the product will be this one is CH2 Here also CH2 HR. So this carbonyl center reduced to CH2 and all are as it is. Next example one. So earlier I have told about the Markovnikov addition. So if we are given here HBr, so that will be at Markovnikov addition product. So what will be the Markovnikov addition and major product? If we are given HBr here, so our major product will be like this. This methyl, there will be bromide. But now we are going another example where the Markovnikov product, not that anti-Markovnikov product, are the major product one. So these are that Markovnikov addition, and this reactant is for the anti-Markovnikov one. So NaBH3. So these are boron hydride oxidation, reduction and oxidation reaction. So these are anti-Markovnikov. This follow the anti-Markovnikov rule. So so for the anti-Markovnikov one, what will happen? So for the anti-Markovnikov one, so the hydrogen will be attack the most substituted one, and boron will be attack least substituted one. So how the reaction process is going on? So if I showing like this, so that our reaction will be, so this one is the methyl. Here we have boron hydride. This and the double bond. So what will happen? So one hydrogen will be attack here, attack this position, that most substituted one, and boron will be attached the least substituted one. So what will the first step will be like this, and that boron will be here attaching. So our first step will be like that. So if you show that BH3, why BH3 is attack here? So if you show that BH3 and this are solvent, so it will be like this: O THF. This BH3 minus is a source of that BH3 minus is a del negative one. So it will attack any pi center source of that hydrogen one. So this BH3 act as a source of the hydrogen, and this hydrogen will be attacking that pi center. So now, so this will be our first step. Now in our reaction medium with the second one, this we are given is 2O2 and NOH. So we have in reaction medium hydrogen peroxide and OH minus. So hydrogen peroxide and OH minus what will be given? So H2O2 and OH minus. So these two are generally produced like this: H minus for the disconnected. So generally these are produced H double. So H2O2 and OH minus, these are generally produced H double minus and water. So what will happen? This H double minus attack this boron center, and this will become this. This will on methyl, so on hydrogen, and our boron will be become like this BH. So in our reaction medium, another OH minus is present. So some process will be like that. This BH2 are going to produce the BOR3, and this BOR3 when they are reduced, so they are produced the alcohol ROH. So this will be like that. Our final product will be like this. So this will be methyl. So this will be our. So anti-Markovnikov of addition, our hydrogen will be attached those site where the more substituted site, and our OH will be attached the less substituted site. But when you go for the Markovnikov addition, so our main this Br will be attached is the more substitute site because there will be produced of carbocation. And here the reaction procedure as completely different. So the what will be our product? So our product will be, and also we have to remember that our product are hydrogen and OH are will be our same site. So generally same phase that hydrogen and OH will be attached. So this will be our methyl. Missing always we are getting that cis product, syn product, anti-Markovnikov addition. So this will be our OH. So today's classes. So this is our last problem. So today's classes what we are, so what we are learn. So first we are learn that earlier I have told about the addition reaction and elimination reaction. So today we are going to addition reaction. So earlier we have telling about the substitution reaction and that elimination reaction. Today we are going to addition reaction and addition of the double bond in a carbonyl in carbonyl center or in a CC bond center. So why this double bond are generally are more pronounced to reaction, because these double bond are generally are mm, pi surface area. So pi surface area are generally more prone to any reaction, because this pi surface area have that sigma and pi bond, but are after produced a products we are getting two sigma bond. So two sigma bond are energetically more favorable as compared to the sigma and pi. So these processes are exothermic one. So our reaction coordinate, the energy diagram product will be more stable as compared to reactant. So they are more pronounced to going to formation of a stable product. So for that, so these are example of one as a Markovnikov addition. And Markovnikov addition first produce some carbocation. If the carbocation is stable one, so then that our stable carbocation produced, so that will be our major product. Then the bromide minus attack from the above the plane and below the plane. So there will be get the fourth product. But when we are given that that our product will be two possibility. One possibility of carbocation are like this. When one cases we are produced 2-degree carbocation. So above one is the 2-degree one. Above one is the 3-degree carbocation and below one is the 2-degree carbocation. So as compared to 3-degree carbocation and 2-degree carbocation, 3-degree carbocation more stable. So this R will be our major product. So that above one will be our major product and this one will be our least product. So if you compare to the energy diagram, so why that 3-degree one will be given that most stable one. So our reaction coordinator is same, but that if you compare that activation energy, so this will be our product. So if you compare the activation energy needed, so so this will be a reaction coordinator. So activation energy needed for that 3-degree carbocation. So this will be like this, but for that 2-degree carbocation, so this will be needed higher energy. So for this reason, the 3-degree carbocation are given the major product. So our major product will be this. So these are the Markovnikov addition. So Markovnikov addition or addition of bromide happen in the more substituted position that in that position. But if you are going the anti-Markovnikov addition, so to trace I have tell you last example. So there will be anti-Markovnikov addition or addition will be happen at that least substituted position. Now the some example of the some reduction. So reduction are happened in the carbonyl center. So if your carbonyl center are reduced, so for carbonyl center are give produce the 2-degree alcohol, and if aldehyde ester and carboxylic acid are reduced, so they are given the 1-degree alcohol. But the sodium borohydride and as compared to sodium borohydride and lithium aluminum hydride, so lithium aluminum hydride are more stronger reducing agent, but sodium borohydride not stronger reducing agent, so it cannot reduce the carboxylic acid and ester center. So if you have seen in this example, so there will be one carbonyl center, one ester center present. But sodium borohydride not reduce the ester center, only reduce the carbonyl center. So carbonyl center we have got 2-degree alcohol. So this will be our product. So this the 2-degree carbonyl center only reduce that ester center as it is present. Now one example where the lithium aluminum hydride, but that not lithium aluminum hydride, there will be some tert-butyl hydrogen reduced replaced by tert-butyl. So these are not strength as compared not strong reducing agent as compared to lithium aluminum hydride. So lithium aluminum what do you do? So if you are given in this reactant lithium aluminum hydride as a reactant, then it all reduced all the this CC bond, also this carbonyl center. But when giving the substituted that lithium aluminum tert-butyl hydride like this, so then it will not that reduced that carbonyl into alcohol. It reduced this carbonyl into aldehyde. So that we have to remember when we are given lithium aluminum hydride, it's reduced to alcohol, but when you are given lithium aluminum tert-butyl, some substituted one, so then that not much stronger reducing agent. So it not reduced. So it only reduced carbonyl to aldehyde, not carbonyl to alcohol. So that this will be our product. Now the next example one. So this carbonyl and there will be amine are 2-degree amine are present. So lithium aluminum hydride, so reduce this carbonyl center. So this carbonyl center become CH2 and RNA as it is present. So our product will be like this. Now the next example one. So here the so if you are given here that HBr, so our product will be like this Markovnikov addition, but that BH3 boron hydride and boron hydride is a source of hydrogen and H2O2 are the oxidizing agent. So what will happen in presence of this? These are a example of anti-Markovnikov addition reaction, and the anti-Markovnikov addition that are the substitution will happen at the less stable one. So this will be methyl. So first this hydrogen from the boron hydride will be attacked here and BH2 will be attacked here. And now this hydrogen peroxide produce this source. So this will be attacked here. So from that rearrangement our product will be like this. So what will be our product? So our product will be the OH will be in the least stable point. So these are anti-Markovnikov, and also remember for the anti-Markovnikov addition, always we are getting syn product, that is cis product. So our hydride source and OH source are in the same phase. So hydrogen and OH will be in the same phase. The addition of hydrogen and OH always in the same phase. So anti-Markovnikov addition and Markovnikov addition tools are different because Markovnikov addition first produces the carbocation, then Br minus is attack, and here the reaction mechanism was totally different. Here the Ba is to directly attach here, and these are produced uh, like this, that OH will be attacked at the less substituted position. So we have to remember, so directly if you goes for product, so anti-Markovitch of addition when the BH3 H2O2 are given, or some H2O2 HBr are given. So also the anti-Markovitch addition also happened in the HBr and H2O2 also. So they also give the anti-Markovitch addition, anti-Markovitch product. So like this product where that substitution will happen at the least level. So for this, if you are given in that example HBr and H2O2, so for that a product would be like this. This one will be methyl, one will be bromide. It's the major product. And here the Markovitch addition, the major product will be Br will be attached at the more substituted center. So as of now, so any further any doubt or anything, we can contact me in this mail ID. So thank you for attention.